Okay, so we're looking at logarithms as the inverse of powers. So, powers then. If I said to you, just check, I'm sure you know this without me asking. So if I said to you, 5 to the power of 2 is 25, okay. If I said to you, 2 to the power of 5 is 32. Is there anyone that's going, I don't know why is 2 to the power of 5 not 25 as well? Are you all happy with that? Okay. Alright. Now, if I said to you, 2 to the power of x equals 32. Right. Now we know what the answer is, don't we? Because we've just done it. But with all maths, there's an inverse to a particular operation that helps you solve something. So, you know, you can, if you've got 2x plus 3 equals something, you can rearrange and do the opposite of multiplying and so on. So if we look at this situation and say, well, how would you rearrange this to make x equals? Because if you can't do that, the only way of solving it is to try and remember what 2 to the power of what makes 32, which is fine. You know, you could probably get through that one, but then if I said to you, you know, 6 to the power of x equals 4,326. So that's not going to be a nice whole number. So there's absolutely no way you're going to be able to figure that one out. Okay. So what we're looking at is if the variable x, the unknown, is a power, we need some way of finding that. Okay. So there's two parts to this really. First of all, you've got to understand how this is written, what notation is used. You're going to have to learn how to use your calculator to solve these things. Okay. Then the next phase will be there are laws of logarithms in the same way that there are laws of dealing with powers. Okay. All right. Do you remember the rules, the laws of indices? Remember them? Let's remind ourselves then. What are the laws of indices? Laws of indices, just to recap. So what would you tell me? What are the laws that you remember?
When you're adding two numbers to the power of
So if I do a to the power of m plus a to the power of something different?
Would be a to the power of m plus n.
Afraid not. Afraid not, actually. Aaliyah?
It would be a to the power of n times.
Okay, yeah. And maybe we need to explain that then. So it's not plus, it is times there, and then it becomes a to the power of m plus n. Do you remember why? Explain it. Well, let's say, for instance, we have 4 to the power of 2 times 4 to the power of 3. If I write that out, I have 4 to the power of 2 is 4 times 4. 4 to the power of 3 is 4 times 4 times 4. And if I'm multiplying them, put another multiply in the middle, I can't tell where the two were separated because it's all multiplies. Okay, so it just becomes 4 to the power of 5. Okay. So in that case, you know, 4 to the power of 1 times 4 to the power of 4 is the same as 4 to the power of 2 times 4 to the power of 3, and so on. So that's where that law comes from. So along the same lines then, what about a to the power of m divided by a to the power of n? What would that be?
A m minus n.
So we've got a to the power of m minus n in that way. Right? Same way, because if we have 3 to the power of 5 divided by 3 to the power of 3, it's like doing 3 times 3, 3 times 3, all over 3 times 3. Right, actually this leads us to an important point I want to just discuss with you. So how does this end up as 3 to the power of 2? What would you say? How would you do it? I'm sure you'll know how to do it, but yeah, what would you do?
Subtract. Yes.
You see the subtract now, yeah, see?
Cancel.
Okay, my question is, why can you do that? But we've got a division. What happens to the 3's that get crossed out?
They cancel out.
They just go bye-bye. Okay? They get,
Cancel out.
well, what does that mean? Cancelled out. Does that mean like go bye-bye as well?
It becomes 0 because
They become 0.
No.
See, that's actually a big
Why?
problem. They don't become 0 because if they become 0, the whole thing would become 0. So they do become Svelica.
You try to simplify it as much as you can. So if you keep dividing 1 by 3 on both, then you can.
So the thing is, go on, what were you going to say?
Yeah, also it's 3 divided by 3, which leaves 1.
Okay, so this is the thing. When we have division, it's the same thing as doing 3 over 3 times 3 over 3 times 3 over 3. That's the 3 on the bottom, times 3 times 3, which we could say over 1, if you want to work it in that way. Because when you multiply fractions, you just multiply all the tops together and you multiply all the bottoms together. So this 3 over 3, it doesn't get waved bye-bye and it doesn't become 0, it becomes 1. Okay, so it becomes 1 times 1 times 1 times 3 times 3. Okay? And that's important because if we make it 0, some people then have a problem with 2 to the power of 3 divided by 2 to the power of 4 becomes what? Okay, 2 to the power of minus 1, but what does that mean then?
0.
See, we've got this problem, haven't we?
Is there a reciprocal? So 1 over 2.
1 over 2. So we learn that as a separate thing, but actually what we have is 2 times 2 times 2, and then if I have 2 to the power of 4, then it's over 2, over 2, over 2, but I've got one more, so over 2, so what goes above it?
1.
A 1. Okay, so that's why when these become 1s, we get left with a 1 over 2. That's why it happens. Okay. So it's good we dealt with that. So we've got these rules of indices. Maybe needs to be recapped a little bit. But we also have rules for logarithms, which we'll learn in the second part. So let's just have a move on to the logarithm stuff now. So looking at page 626, okay, if we look at the example 1, we say 2 to the power of 5 is 32. We're fine with that, we've done that, we're happy enough. Right, everyone with me? All we're looking at is how we can write that in a different way. Now, here, 5 is called the exponent. 2 is called the, anyone know? Base. So this is what we use. That's the notation we use. Okay. So what we can then say, the way we rearrange this, is we've got to do an inverse, and the inverse to make the exponent the subject of what we're talking about, because that's what we want to find. So we can say that the logarithm to the base 2, okay, log to the base 2 of 32 equals 5. So what we're saying is if it's log to the base 2, the base is 2, 2 to the power of 5 makes 32. Okay? So that's how we can write it in. We've got exponent form, we've got logarithmic form. Right. So again, we'll take the next example, which is log to the base 4 of 64 equals 3. If we had to write that one in exponent form, what could we say? Ella, any ideas?
4 to the power of 3 is 64.
Yeah. So we go from logarithmic form to exponent form. Right? Simple as that. Now what I'll do now at this point is just check with the calculator. Alright? So have you got your calculator? Alright. Now what we've got with our calculator, we've got a nice situation in that because we've all got modern calculators, we don't have the problem that we used to have where we only had a log to the base 10 button. So on your calculator you will see log there. Now log is log to the base 10 only. Alright? But that's not very useful if you want to find log to base something else. There are log conversion, there's a log conversion formula we look at, but just to start with, we've got it easy. So if you press, I think, let's check, is it the math button? Yeah, press the math button on the side of your calculator. Alright? In the math menu, rather than number or complex or math menu, scroll down to A. So you've got all the way down to 0 and then A, and it says log base. Right? Press enter on that, you'll get a nice little log with 2 squares. Alright? So just to check then that log to the base 2 of 32 is, put a 2 in for the log to the base square, put a 32 in for the other one, and press enter, and you will get the answer 5. Right. So easy thing with your calculator, not a problem, but now you know how to do it. So if we then do log to base 4 of 64, right. So just now, let's see how we've progressed with your understanding. If I go back to this first thing I stated up here, if 6 to the power of x equals 4,326, any ideas what you do already now? Ivan?
You put log to the base of 6
Log to the base 6 of
4,326
equals
equals x.
x. So, in this case, using your calculator, what's x? Go on, Ricky.
Around 4.67.
So x is 4.67, you think, to 2 decimal places?
Yep.
Okay. So that's how we can solve those ones. Alright? So, based on the fact that that's quite simple for you, I'm going to ask you for exercise 31A, I'm going to get you to start with, well, you're going to do question 1, 2, 3, but only the bottom line. So question 1, I, J, K, L. Question 2, E, F, G, H. Question 3, I, J, K, L. Okay? And then we'll start getting on to questions 4, 5, and 6. So just to start with, now, go do the first few questions. So question 1, bottom line, question 2, bottom line, question 3, bottom line. On that first page. Everyone okay with that?
Yeah.
626. Okay, let's have a look. Just a couple, so if everyone's with me. Let's have a look at 3p. I know you have, I didn't ask you to do that one, but come on, you stupid thing. 3p. So we're mixing a bit of what we know with surds with what we've got with logarithms. So we're going to have a look at log to the base 2 of 1 over 4 root 2. So we've got to write that in exponent form. So, well, no, find the value of without writing a calculator. So how do we do that? So we're going to put it in exponent form. So what do we do? I'm going to find the value of that without using a calculator. Any ideas? So let's write it in exponent form. So we've got to find the value of it. So finding the value basically means we're doing equals something. Yeah, if we're finding a value. So we're saying equals. The value is the unknown. We'll call that x. So how can I then rewrite that? Okay.
2 to the power of x equals 1 over 4.
2 to the power of x equals 1 over 4 root 2. Okay. So we've got to find what x is. Now it seems a bit weird that we've put x back to the power. What are you going to say?
I was going to say we can start off by, since the answer is in reciprocal form, we
Well,
know that the function is
okay, before we go down that route, can we ask, so if I've made the unknown the power now, because that seems kind of weird based on what I was telling you about, if the unknown is the power, it's difficult to find it. There is one way that you have done before where the power is then easy to find, and it's when both sides of an equation have the same base. You know, so if I say to you 3 to the power of x is equal to 3 to the power of 7, the fact that the x is a power and it's unknown it's not a problem, is it? Because what do we know in this case? That x equals 7, right? And one that you may have done before, so for instance 2 to the power of x is equal to 8 to the power of 2. How would we go about solving that one, for instance?
You can find them separately. So square root of 2 will be 2 to the power of 0.5.
Which one are we talking about here? I want to do this one. 2 to the power of x equals 8 to the power of 2. How do you find what x is in that case? Because it's not 2, is it? Yeah. Exactly. So we need to get to the same base. So 8 would be 2 to the power of 3. And that is squared. Now using laws of indices that hopefully you remember. 2 to the power of x is equal to 2 to the power of 6. Because when it's like this, you multiply. So 2 to the power of 6. So x equals 6. Now, back up to this one, we've got the same situation. What we're trying to do is get the base to be the same. Alright? So with a calculator, log to the base 2 of something nice and easy, but without a calculator, we've got to do it a different way. So we've got to try and get it to be 2 to the power of something, and that's nice because I've got a root 2, which is linked. So, Ricky, you're going to start us off. What did you want to do?
I was going to say we already know that the x will be negative because the answer is in reciprocal form.
So what do we do with this side though? So we can change it to something else. Anyone? We've got to have powers.
4 root 2 to the power of -1.
Okay, so 4 root 2 to the power of -1. Everyone okay with that? Yeah? Anyone want to ask why? No? You all know. Good? Everyone nodded. Okay. What do we want to do now? Eva?
We can find that 4 is 2 to the power of 2 and root 2 is 2 to the power of 0.
Okay, so we've got 2 to the power of 2 times
2 to the power of 0.5.
I'm going to put a half because I prefer fractions. And all of that is still to the power of -1. Okay. Aaliyah, what would you do next?
Would you use the indices laws?
Yeah.
So because it's like a times, you would add the pieces, so it would be 2 to the power of 2.5.
2.5, yeah. So I'm going to write 5/2, just to keep it simple. Okay, all of that is to the power of
A -1.
-1. Okay. Ishan, final step. Two plus a half, 2.5. 5/2, 2.5. I mean, here we do, it's 2 to the power of 2 plus a half, which is 2.5. It's just a bit, for me it's a bit messy like that. So I convert a mixed number into an improper fraction, just to keep it as a nice one single fraction. That's all. So what do we do now? We've already done it once. When you've got a power inside a bracket and then raised to another, you multiply. So it becomes
2/5.
No.
2/5.
Nope. Ella, do you know? When you multiply the two powers?
1 over 2.
I think you're all complicating yourself. It is 5/2 times -1, which is -5/2.
But wouldn't the
No, we're just multiplying the powers. You know, the laws of indices. Do you remember that one? That is a to the power of m raised again to the power of n is a to the power of m times n. So it's the same thing. Now, again, we could rewrite this in a different way, -2 to the power of -5/2, but we don't want to do that. We just want to now finally state that x equals -5/2. That's what we wanted. That's what we need. Okay, so that's finding x. So you can see how sort of understanding the way logarithms are converted to exponent form and vice versa, and knowing all your exponent laws are going to be important. Okay, so can I get you, homework-wise, but not necessarily proper homework, I guess, before next time, is to revise your exponent laws. Okay, make sure you remember them all. Have a quick read through the book, let's revise your exponent laws so you're happy with them.